Here we're being asked to find the component form of the sum of the two vectors u and v, with the directional angle of vector u being theta u and the directional angle of vector v being theta v. We're told that the magnitude of u is 4 and that theta u is equal to 60 degrees, and the magnitude of v is 4 and that theta v is equal to 90 degrees. We know from our formula that u is equal to the magnitude of u times the components cosine theta, sine theta. We know the magnitude of u, we can find cosine of 60 degrees and we can find the sine of 60 degrees. We know the cosine of 60 is 1/2 and the sine of 60 is square root of 3/2. So u is equal to 4 times 1/2 and square root of 3/2, or 2 and 2 square root of 3. To find v, we do a similar thing, so we multiply the magnitude of v times the cosine of theta, sine theta. Here theta is 90 degrees, so this is cosine of 90 and the sine of 90. We know the cosine of 90 is 0 and the sine of 90 is 1, so this becomes 4 times 0 and 4 times 1, or just 0 and 4. So since we want the sum in the components form, we can add the components of u plus the component of v. So we know it's going to be u1 plus v1, it's going to be 2 plus 0, which is 2, and u2 plus v2, so it's going to become 4 plus 2 radical 3. So here is the sum of vectors u plus v in its component form. So here we're told that we have two forces, one with a magnitude of 125 newtons and the second with a magnitude of 300 newtons, and both of these forces are pulling on this hook. Now the angle between the two forces is 45 degrees. So here we have our diagram. We're asked to find the direction and magnitude of the resultant force. We know from our vector addition that when we add these two forces, we can use our parallelogram, so our resultant would be somewhere in here. So this is what we're trying to find, the resultant, which is the sum of these two forces. Now if we call this top force u and this bottom force v, we know that u is equal to the magnitude of u times cosine of theta I plus magnitude of u times the sine of theta j. So cosine of 45 is 1 over the square root of 2, so this becomes 125 over the square root of 2i, and this becomes 125 over the square root of 2j. For v, this our angle, since this is horizontal, our angle is 0, so this becomes 300 times cosine of 0, which in the cosine of 0 we know is 1, so it's 300 times 1 times I, so it's 300i. The sine of 0 we know is 0, so all this goes away, so for v we only have 300i. Since we're trying to find the sum, the resultant, we know this is u plus v. So u plus v would be the u1 plus v1 and u2 plus v2. So u1 plus v1 and u2 plus v2. Since our v2 here is 0, this is just 125 over the square root of 2. We know to find the magnitude, this would be this squared plus this squared and the square root of that. Because the magnitude of our vector is the square root of a squared plus b squared, or v1 squared plus v2 squared. And this comes out to be 398.32 newtons. So our resultant here would be 398.32 newtons. To find our angle, we know theta is equal to the arctan of b over a. So this is our b and this is our a. So if we take 125 over the square root of 2 and divide it by all of this and then find the arctan, we get 12.8 degrees. So our resultant is acting in this direction, which is 12.8 degrees, and has a magnitude of 398.32 newtons.